Is graphing inequalities. Graphing inequalities, if you go back to like number lines, so if you have a number line and you want to graph, let's say x is greater than 4, on your number line you're going to start at 4. Because it's only greater than, you would do an open circle and then your answer includes everything greater than 4, so we're going to shade to the right. Okay? If we're graphing x is less than or equal to -6, on the number line, again you would start at -6, and then because it includes, because it's less than or equal to -6, you start at -6, you go to the left, and you shade everything left of -6, including -6. So notice I have an open circle if it's just greater than, but I have a filled-in circle if it's less than or equal to. So what we're gonna do here in graphing inequalities is, if we're graphing an inequality that has just greater than, or less than, we're gonna be using a broken line, just like we did an open circle here on the number line. If we're graphing inequalities that have greater than or equal to, less than or equal to, we're gonna use a solid line. What this means is if it's just greater than or less than, the answers or the solutions are not included any points on the broken line. If it's greater than or equal to or less than or equal to, our answers will include whatever points, whatever coordinate points we have on the line. Here's an example. What if I wanted to graph x is greater than 4? Not on a number line this time, but I want to graph it on a coordinate plane. So here, if I have 0, 1, 2, 3, 4, this is my boundary line. So I'm going to draw a broken line right here through x equals 4, vertical line. And then everywhere over here is going to be shaded, because every single coordinate point in that region will have a coordinate value greater than 4. So for x is greater than 4 on the coordinate plane, it's going to be a vertical line through 4, and every single coordinate point over here would have an x value. For example, x is going to be what, 5, 6, 7? It's going to be 7, 0 right there. So every point over here will have an x value greater than 4. What if I wanted to graph on my coordinate plane, x is less than or equal to -6? So here I go to -6, so that's 0, 1, 2, 3, 4, 5, 6. So -6 is over here. And because it's less than or equal to -6, this time I'm going to use a solid line through -6. And because it's less than, I'm going to shade everything left of -6. So every coordinate point over here to infinity will have a coordinate value x that is less than or equal to -6. And notice I use a solid line because these points are also less than or equal to -6. What if I want to graph something that looks like, say, y is greater than 2? Same thing. So now I'm going to go to the y, and here 0, 1, 2. Right here is where y is equal to 2, and everything above that, my y coordinate points will be greater than 2. So that would be the graph of y is greater than 2. Every coordinate point up here will have a y coordinate that's greater than 2. What if your equation is in slope-intercept form? For example, I give you y is greater than 2x minus 3. How would we graph that? It's going to be the same thing like we're graphing a regular equation. Y is greater than 2x minus 3. I know my y-intercept is -3. I know my slope is equal to 2, which is 2 over 1. So I'm going to rise 2 and I'm going to run 1. So how would I graph that? I'm going to start at my y-intercept of -3. So 0, 1, 2, 3. So I have a point at -3. And then my slope is I go up 2 and over 1, up 2 over 1. So I have a few points. But then because it's only greater than, I'm going to use a dotted line. So I'm going to use a broken line through all of those points. So I use a dotted line. Now I need to figure out Do I shade this side of the line or do I shade this side? And one way that you can check all the time, you can test, for example, I can test the point, I can test the origin, which means I'm going to plug in x equals 0, y equals 0 in my original equation and see what kind of statement it gives me. So I'm going to plug in y is 0, so I replace y with 0. That x is 0, sorry, 2 times 0. So I have 0 is greater than 0 minus 3, 0 is greater than negative 3. Is 0 greater than negative 3? No, that's not true. So it means that the origin is not a solution, so I'm going to shade the side of the line that does not have the origin in it. And so I would shade down here. So it means every single coordinate point on this side of the line would make that inequality true. Y is greater than 2x minus 3. Last one. Let's do one that has standard form, finding the intercepts. So let's do 2x minus 3y is less than or equal to 6. This time we're going to find the x and y intercepts. So, let's find the x-intercept. What do we know in the x-intercept? Y is equal to 0, right? So I'm going to plug in y equals 0. So I'm going to have 2x. I'm just going to use an equal sign right now. 2x equals 6. If I go sides by 2, x is equal to 3. So my x-intercept is at 3. So I have an x-intercept right there. Let's go find the y-intercept. Now the y-intercept, we know that what? X is equal to 0. So I'm going to put 2 times 0 minus 3y. I'm going to just use a regular equation right now. Divide both sides by negative 3. So y is equal to negative 2. So my y-intercept is at negative 2, 0, negative 2 right here. Because it's less than or equal to, I'm going to draw a solid line. So I'm going to draw a solid line through my two intercepts like that. And then the last thing I want to do is, do I shade this side of the line or do I shade down here? I'm going to go test the point. So I'm going to plug in 0, 0 again. So I'm going to test 0, 0. So let's plug in 0. 2 times 0 is 0. Minus 3 times 0 is 0. Is less than 6. 0 is less than or equal to 6. Is that true or false? It's true. So it means that 0, 0 is a solution. So I'm going to shade the side of the line that has 0, 0. So I'm going to shade this side of my line because it has 0, 0 in here, which is a solution. And that's pretty much how we're going to be graphing inequalities on the coordinate plane. Let's go.